Hello and welcome to the chapter on computer system overview. This is the part 1 of this particular chapter, and in this part we are going to deal with the introduction to computer system. So let's start with the basics and let's start with the definition of a computer. So what is a computer? A computer is an electronic device that takes raw data as input and after processing converts them into a meaningful output. So what a computer is? It is an electronic device that takes raw data as input. What is the meaning of this part, raw data as input? Like when we interact with the computer, we use various devices like input devices like keyboard, mouse, etc. in order to interact with the computer. Now while interacting with the computer, we give certain data from outside. That data that we give from outside is known as the input. The computer takes the input, it processes them, means it calculates them, and then it converts them into a meaningful output. So whatever output is there, it is displayed with the help of a output device like the monitor. Let's see these terms in a little bit more details. So what are the important terms that we got here? The terms are data, input and output. So let's start with the first term, that is data. Now what is the meaning of the word data? Raw facts or figures are referred to as data. So let's say we want to prepare tea. Now in order to prepare tea, we require certain ingredients like tea leaves, water, milk and sugar. Now these ingredients are known as data because these are some raw facts. Now if I talk with respect to a computer system, data may be some numbers like 5, 8, Neha, etc. So always remember, raw facts and figures are referred to as data. Let's go to the next term, that is input. What is input? The process of sending data from an external device to the computer is called input. Now whenever we interact with the computer, that means what we are doing? We are sending some data from an external device to the computer. That process of sending data from an external device to the computer is called input. Now how do you do the process of input? The process of input is done with the help of devices known as input devices. So the input devices are used to input data to a computer. Some examples of input devices are keyboard, as we all know, mouse and maybe joystick. Joystick is used for playing games, as you all are very familiar with it. Let's go to the next term, which is the output. Now after we send data through the input devices, the data is processed and then converted into a meaningful output. That means the data that is sent from the computer to the various output devices is known as the output. Examples of output devices are monitor, printers, speakers. Now if you think a little bit deeper way, then you will find that we use monitor, printer or speaker to receive something. So whatever instruction we give from the outside, it is processed and it is displayed via the monitor. Now if we want it in a printed form, then we require the help of printer. Now if I want to play some music, the music we will be able to listen to the music with the help of speakers. So these devices are known as output devices. Okay, now I think now the definition of computer is clear. So what is a computer? Let's go to it again. It's an electronic device that takes raw data as input, processes them, and after processing it converts into a meaningful output. Now we need to know about few more terms. The first term is hardware. What is hardware? The physical electronic components of a computer are called hardware. So the components of a computer that we can touch are called hardware. Some examples of hardware in a computer are the devices attached to a computer like keyboard, mouse, CPU and the monitor. These are some examples of hardware. Next is software. What is software? A software may be defined as a set of related computer programs designed to solve a particular task. Now if we have a number of programs which is destined to do a particular task or to solve a particular task, then it is known as a software. So it is a set of related programs used for solving a particular task. Some examples of software may include MS Word. It is used for which task, solving which task? It is used for solving the task of making documents. Next example of software may be MS Excel. It is used for data analysis or certain calculations, for graphical analysis. Next we can have PowerPoint. It is used for making presentations. We can have Photoshop also. It is used for photo editing. So it is a set of related computers, it is a set of related programs designed to solve a particular task. So each software is designed in such a way that it can perform a particular task. Now let's go and see the block diagram of a computer. This is how a block diagram of a computer looks. Many people can draw it in different ways, but these are the components which you will find common in all the block diagrams. Now let's try to understand the block diagram of a computer. First thing we have is the input device. These input devices are used to send data to a computer, as we have already seen. Now the data that we send from the input device, the data goes to the memory. We have another main component of a computer which is known as the CPU. CPU is known as the brain of the computer. Now there are two main parts of CPU. Actually there are three, but in the block diagram we generally show only two. They are ALU. Okay, the CPU is responsible for the overall working of the computer. Like our brain is responsible for the overall working of the human body, similarly the CPU is responsible for the overall working of a computer. Now the different parts of a CPU are, first is ALU, which stands for Arithmetic Logic Unit. Next is CU, which stands for Control Unit. Let's see the work of ALU in brief. The ALU is responsible for performing arithmetic operations like plus, minus, into, divide, etc. and taking logical decisions. Logical decisions means to check whether something is greater than the other thing, for like the comparison thing, like greater than, less than, all these things are known as logical decisions. Arithmetic Logic Unit is responsible for performing arithmetic operations and taking logical decisions. Next we have the Control Unit. Control Unit is responsible for sending or receiving the control signals. Okay. Now here we see some dotted lines. The dotted lines represent the control signals. If you look at the diagram carefully, the control signals are connected from the control unit. As you can see, the control unit is connected to each and every component of the computer. These are the control signals, and the solid lines, they represent the transfer of data from one device to other. Now under the control of control unit itself, the data comes from the input device to the memory. After that, the data is processed in the ALU and then the result is stored back in the memory. So data comes from the input device to the memory, then the processing takes place in the ALU, and after the processing takes place, the result is again sent back to the memory. Then from the memory, the processed results are converted to such a form that can be understood easily by human beings. And then the output, that is the result, is displayed with the help of a output device. This is how a computer system works. Let's try to segregate and understand deeply about some of these components. First is, what is a CPU, which is the brain of the computer. CPU is the main control center and processing unit of a computer. So all the controlling of the computer happens with the CPU. Therefore, while purchasing a computer, I mean a desktop computer, the main thing that we focus on is the CPU, because it is the main control center and the processing unit of a computer. It is also known as the brain of a computer. It guides, directs and governs the performance of a computer. Now, how a particular computer will perform, it will depend on how powerful the CPU of a computer is. Now, let's see what are the components of a CPU. They are ALU, CU, and we have one more component which is not shown in the block diagram, but I'll be discussing it here, which is the register. So, three main components of a CPU are ALU, CU, and the registers. Let's discuss about the ALU. ALU stands for Arithmetic and Logic Unit. It is responsible for performing arithmetic operations and taking logical decisions. Arithmetic operations includes plus, minus, into, division, etc. And logical decision includes the comparison operators or the relational operators like greater than, less than equals to, greater than equals to, not equals to. All this comes under logical decisions. Now, let's take a part of the block diagram of a computer. Now, let's say we want to compute 5 plus 6. We means the computer wants to compute 5 plus 6. Let's see how this computation will take place. Now, for that, let's take a part of the block diagram of a computer. So, this is a part of the block diagram of a computer. Now, whatever input we give through the keyboard or through any other input device for that matter, now those input remain stored in the memory. Then from the memory, it goes to the ALU, that is the Arithmetic Logic Unit. Now, here in this case, we have taken 5 plus 6 into account. So, 5 plus 6 is calculated in the ALU, and then the result, the process result, that is 11, is sent from the ALU back to the memory. The same goes with other arithmetic operators like minus, into, division, etc. And in a similar process, the logical decisions are also taken with the help of the relational operators like greater than, less than, etc. Next, we come to control unit. The control unit is responsible for guiding the interpretation, flow, and manipulation of all data and information in a computer system. Now, control unit, what it does, it guides the flow of data. It will not do any work by itself, but just it will guide and see if everything is working properly or not. Therefore, it acts as a supervisor by controlling and guiding the operations taking place in a computer. How it acts? It acts like a supervisor. Let's say in an office, what is the role of a supervisor? Supervisor will not do the work by himself or herself. Supervisor will guide and see if all the operations are taking place properly or not. And if any help is required, then the supervisor will guide. Remember this word, then you will be able to write about control unit in a better way in your examinations. So, control unit is known as what? It is known as the supervisor because it guides the interpretation, flow, and manipulation of data and information in a computer system. Let's go to the last part of the CPU, which is register. Registers are the smallest data holding elements that is located in the CPU. A register temporarily stores frequently used data, instructions, and memory address that are to be used by the CPU. Now, whatever data is to be used frequently, those data and instructions are to be stored. Now, who stores it? It is not stored by the memory. For faster processing, whatever frequently used data is there, it is stored by the CPU itself. Therefore, we say that register are the smallest data holding elements. Why smallest data holding elements? Because you cannot store a lot of data in register. It is basically a small amount of memory basically used for storing the memory address and some frequently used data. I hope you have understood all the things that are discussed in the part 1. We will discuss in part 2 about different types of memory. I hope that this session was useful. Thank you very much. Hello and welcome to the chapter on Computer System Overview. This is the part 2 of this particular chapter, and today we are going to deal about memory. So let's get started with what is a computer memory. See, we as human beings retain information in our memory. That's the human memory. Similarly, computer retains information in its memory known as computer memory. So what's the formal definition of computer memory? A computer memory is the storage space in the computer where data and instructions required for processing are stored. So in order to store the data and instructions in a computer, we require a storage space which is known as computer memory. The memory of a computer is divided into large number of small parts called cells. So as you can see here, this is a part of the computer memory. The computer memory is divided into large number of small parts. These are known as cells. Each of the cells is further broken down into small parts known as bits. As you can see, this is a complete cell, and one cell is divided into certain smaller parts. These small parts are known as bits, B-I-T-S. What is the meaning of bit? A bit means a binary digit which is either 0 or 1. Each bit within a cell has a unique address which is in the range of 0 to memory size -1. Now, each of these bits within a cell has an address. This address is known as the memory address. What is the range of this memory address? The range is from 0 to memory size -1. Now here, what is the size of the cell that you are seeing in your screen? The size is 8. Therefore, the memory address will be from 0 to memory size -1. That means it will be from 0 to 7. Because the size is 8, the memory address is from 0 to 7. I hope that this is clear. Let's go to the first type of memory known as primary memory. What is primary memory? The type of memory that holds only those data and instructions on which the computer is currently working is called primary memory. See, in a computer there are lots of data and information, but a computer will work only on a group of data and information, or only on, let's say, only on one software it will work at a time. So that type of memory which holds only those data and instructions on which the computer is currently working or presently working, it is known as primary memory. So the primary memory of a computer is divided into two types. It is RAM and ROM. Further, RAM is divided into two types known as SRAM, that is static RAM, and DRAM, that is dynamic RAM. Similarly, ROM is also divided into certain parts known as PROM, EPROM, EEPROM, Flash EEPROM, and mask ROM. We will discuss about all the different categories of RAM and different categories of ROM also in the upcoming slides. So let's begin our discussion with RAM. RAM stands for Random Access Memory. It is a type of memory in which the memory cells can be accessed for information transfer from any desired random location. Now, if we are accessing the memory cells from a random location rather than in a sequential manner, it is known as RAM. It is a volatile memory, hence it is temporary in nature. Volatile memory means, see, RAM is a type of memory in which the currently running programs are stored. Therefore, as we switch off the computer, the information from the RAM gets away. Therefore, it is said that it is a volatile memory and hence it is temporary in nature. What are the different types of RAM? RAM is divided into two types. First is dynamic RAM and second is static RAM. This is how a typical RAM looks like. Let's start with dynamic RAM, which is the shortened form of which is DRAM. Dynamic RAM, it is composed of capacitors. This is how a capacitor look like. If you open the motherboard of a computer, or if you just observe the motherboard of a computer, you will see these types of capacitors. Capacitor stores charge. It is typically used as main memory of a computer. Now, main memory of a computer is made up of DRAM. It is to be refreshed periodically to maintain the charge in the capacitors. As I have already mentioned that capacitors store charges. Now, in order to retain or maintain the charge of the capacitors, these RAMs are to be refreshed periodically. Its access time is more, that is, it is slower. Now, what do we mean by access time? Access time means the time taken to retrieve data from storage is called access time. Now, as we request the data, you will not get it immediately, right? It will take some time. That time is known as the access time. It is the time taken to retrieve data or take out data from the storage. Here, in case of DRAM, the access time is more. That means it is a slower form of RAM. Next up is SRAM, that is static RAM. It is made up of flip-flops. What are flip-flops? Flip-flops are binary cells capable of storing one bit of information. Flip-flops, they store one bit of information. Flip-flop is a very detailed mechanism. You will get it in your higher classes. Now you just need to know that static RAM is made up of flip-flops and dynamic RAM, it is made up of capacitors. It is typically used as cache memory in a computer. Cache memory is a very high speed memory. We will get cache memory in details after a few minutes. Now, in order to design the cache memory, static RAM is used. It does not require periodic refresh to maintain data. Since it is made up of flip-flops, therefore, no periodic refresh is required in case of SRAM. It has faster access time. Faster access time means it is a faster form of RAM. Let's go to ROM, which is known as read-only memory. It is a memory unit that performs the read operations only. Now, in ROM, the information is already stored. You just have to access the information. That means it performs the read operations only. This is how a typical ROM looks like. It is a non-volatile memory. That means information stored in ROM is permanent. The information stored in ROM is made permanent during the hardware production of the unit. When ROM is made by the hardware manufacturers, at that time only the information in the ROM is permanent. It stores instructions required for booting the computer. Now, what is the meaning of booting? When we press the power on key in the CPU, then it takes some time to start the computer. Now, for starting the computer, certain programs are required. Okay, and who helps in starting the computer? ROM helps in starting the computer. So, booting is the process of starting the computer. What are the different types of ROM available? They are PROM, EPROM, EEPROM, Flash EEPROM, Mask ROM. Let's start our discussion with PROM. PROM stands for Programmable Read-Only Memory. This is how a PROM looks like. It is also known as OTP, that is one-time programmable. That means you can program a PROM only once, not more than once. Once the PROM is programmed, the information written is permanent and cannot be erased. Once you write information in the PROM, you cannot erase the information again. Therefore, while you are manufacturing PROM, if some mistake occurs, then that chip is discarded and the new PROM is to be created, which is a disadvantage of PROM. As you can see in the last point, if a PROM is programmed with an error or needs updation, the chip is discarded and a new PROM is created, replacing the old chip. Next, let's go to EPROM, which stands for Erasable Programmable Read-Only Memory. EPROM is a type of ROM that can be erased and reprogrammed if needed. Now, the distinguishing feature between PROM and EPROM is that EPROM can be erased after writing the information also. Now, how is reprogramming done in EPROM? Reprogramming is done by exposing the chip to UV radiation. Now, the chip, that is EPROM, is exposed to UV radiation, and in that manner reprogramming is done in case of EPROM. And EPROM chip is distinguishable by small quartz crystal circle window that exposes the chip so that it can be reprogrammed. Now, as we have already learned that reprogramming is done by exposing the chip to UV radiation, therefore, this is how an EEPROM looks. In the middle, you will see that there is an exposed part. Why this exposed part is there in EEPROM? So that it can be reprogrammed by exposing it to UV radiation, which is not the case with PROM, where no exposed part is there because it's not required, because it cannot be reprogrammed. PROM cannot be reprogrammed, but EEPROM can be reprogrammed using UV radiation. I hope it is clear. Let's go to the next type of ROM, which is EEPROM, which stands for electrically erasable programmable read-only memory. What is EEPROM? It is a PROM that can be erased and reprogrammed using an electrical charge. In case of EEPROM, we can erase and reprogram using UV radiation, but here in case of EEPROM, the reprogramming is done by using an electrical charge. This process of erasing electrically is faster as compared to EEPROM. Since we are using electrical charge here, the process of erasing is faster as compared to EEPROM. In this process, selective bytes can be erased, unlike UV EEPROM, which erases fully. In case of EEPROM, we have to erase the entire chip even if there is a small mistake. But in case of EEPROM, we can erase selective bytes also. Therefore, it is better as compared to EEPROM. This is how EEPROM looks like. Next, let's go to flash EEPROM. What is it? It is similar to EEPROM but faster. That means the mechanism of flash EEPROM and EEPROM is the same, but flash EEPROM is faster as compared to EEPROM. The eraser of the entire contents takes less than a second. In less than a second, you can erase the entire contents from flash EEPROM. The data from flash EEPROM is erased fully and not selectively. You will not erase the data from flash EEPROM selectively. You will erase it fully. This is how flash EEPROM looks like. Let's go to the last type of ROM, which is the mask ROM. What is it? It is a type of ROM in which the contents are programmed by the IC manufacturer. Now, whoever makes the ROM, they will program the contents of mask ROM. It is masked off during production. Masked off during production means how the programming is done, you cannot see it. This is done in order to protect the integrity and the privacy of the hardware manufacturer. Masking primarily serves as a sort of intellectual property protection so that other manufacturers cannot copy their code, reserving reproduction of the product to the IC manufacturer so that it serves as an intellectual property protection. Therefore, ROM in case of mask ROM is masked off during production. This is how a mask ROM looks like. Now we are done with primary memory. Let's go to secondary memory. So what is a secondary memory? It is the type of storage devices that is used to store large amount of data permanently. See, in case of primary memory, you cannot store large amount of information. For example, when you buy a new computer, what is the typical size of RAM? The typical size of RAM is about like 4 GB or 8 GB. But what is the size of the hard disk or the solid state drive that you have? Its typical size is maybe 500 GB, maybe 1 TB, like that. So those are known as secondary memory. Secondary memory are storage devices used to store large amount of data permanently. For permanent storage, secondary memory is used. So secondary memory, let's see some categories of secondary memory. First is magnetic storage based secondary memory. The examples are hard disks and floppy disk. These have some mechanical moving components. These are example of magnetic storage based secondary memory. They store information permanently. Second category is flash memory. They do not have any moving components, therefore it is faster as compared to magnetic storage based. Examples are pen drive and solid state drive, but they are expensive as compared to magnetic storage based secondary memory. Next type of secondary memory is the optical media. They use some property of light. They are typically circular in shape, which consists of CD, DVD or Blu-ray disc also. Next, let us go to the cache memory. What is cache memory? It is a high-speed memory located inside the CPU in order to speed up access to data and instruction. Now, if you require data and instructions immediately, then cache memory is used. Typically, the recently used files are stored in cache memory so that CPU can access it immediately. Now, how does a cache memory work? Let us see in brief. It is a portion of memory made up of high-speed SRAM. Now, cache memory is made using high-speed SRAM, that is static RAM. Whenever some data is required, the CPU first looks at the cache. Now, instead of looking in the secondary memory or in the dynamic RAM, at first the CPU looks at the cache memory whenever some data is required. If the data is found in the cache, well and good, CPU does not access memory and hence the process becomes fast. So since why it is a high speed memory? Because it is located in the CPU and at first CPU will look for the data in the cache. If it finds it in the cache, well and good, and if it does not find in the cache, then only it will look in the memory. But if it finds it requires information in the cache, then the access time will be much faster. Now let's see the units of memory. See, for representing various physical quantities, like for representing liquid, we use some units like liter, milliliter. For representing like distance, we use units like meter, kilometer, etc. Similarly, for representing memory also, we use different units. What is the elementary unit of the memory? A bit is an elementary unit of the memory. 8 bits is equals to 1 byte. Now, why have I converted bits into byte? That's because 1 byte is the smallest unit that can represent a data item or a character. You cannot use the elementary unit, that is bit, for representing something. For representing even the smallest of character like full stop or comma or A, B, C, D like this, the minimum amount of memory that you require is 1 byte. Let's know about another term called as nibble. What is nibble? A group of 4 bits is called a nibble. So 4 bits is equals to 1 nibble. We have other higher units of memory which includes KB, MB, GB, TB and PB, which stands for kilobyte, megabyte, gigabyte, terabyte and petabyte respectively. These are its like interconversions. 1 KB is equals to 1024 bytes, 1 MB is equals to 1024 KB, 1 GB is equals to 1024 MB and 1 TB is equals to 1024 GB and 1 PB is equals to 1024 TB. Now we will recognize a certain pattern in these memory units. The pattern is that every higher memory unit is equals to 2 to the power 10 of its lower unit. 2 to the power 10 is equals to 1024. Now if I take the example of kilobyte and megabyte, what is the next higher unit of KB? It is MB. So 1 MB is equals to 2 to the power 10 KB, that is 1024 KB. That's all about the memory. I would like to show you something about like primary memory and secondary memory. Now let's say here I have various images here. Let's open this image. Now before opening it, it is located in the secondary memory, which is solid state drive in my case. Now as I double click it, it will come from the secondary memory to the primary memory, that is RAM. As I have said, RAM stores the data which we are using currently. Okay, I hope you have understood a little bit about memory in this part. In the next part, I'll discuss more about this chapter known as computer system overview. Thank you very much. I hope that this session was useful. Hello and welcome to the chapter on computer system overview. This is the part 3 of this particular chapter, and today we are going to discuss about software and its types. Let's see the contents of this video. Here we'll be basically starting off with the definition of software, meaning what is a software. Then we'll basically be seeing about the different types of softwares, which are system software, within which we'll be studying about operating system. We'll be studying about different types of language processors like compiler, interpreter and assembler. Then we'll be studying about device drivers, and then we'll be studying about application software, within which there are packages, customized softwares, system utilities and developer tools. So these are the topics that we will be covering in this video. So let's get started with the definition of software. So what is a software? Let's say we purchase a computer, a very expensive computer from the market, but there is no software installed in the computer. Will we be able to use that machine? No, we won't be able to use that machine. That machine will literally be of no use to us. So what we have to do? We have to throw it in the garbage bin. So how to make use of the computer? For making use of the computer, we require something known as the software. Which brings us to the initial question as to what is a software. So what a software is? It is a set of programs that govern the operation of a computer system and make the hardware run. What it is? It is a set of programs. So in a software, we'll be having a number of programs which will help in making the hardware of the computer run. Okay, so software is a set of programs which will help you in running the program and running the computer. There are different types of softwares available, which are basically softwares can be classified into two categories. They are system software and application software. System software can further be classified into three categories, which are operating system, language processors and device drivers. And application softwares are classified into four categories, which are packages, system utilities, customized softwares and developer tools. Let's start with system software. So we know that a computer is a mere machine that knows nothing of itself. Each and every instruction should be given to the computer. These instructions are provided with the help of what? These instructions are provided with the help of software. So system software is such a software that controls the internal operations of a computer. So the definition says that the software that controls the internal operations of a computer is called system software. Internal operation means it will basically interact with the hardware so that you can run all other programs and all other application softwares over it. Okay. So what are the different types of system softwares we'll be seeing now? So what are the different tasks that a system software does? The first task is it reads data from the input devices. So whenever we are interacting with the computer, we are giving some data via the input devices. Input devices means the devices like keyboard, mouse, etc. So reading data from the input devices is one of the major tasks of system software. Another task of system software is to transmit the processed information to the output device. Output devices examples are, it may be monitor. So after we give the input will be processed, and after that the result will be shown via the output device. So this process of transmitting the processed information is also done with the help of system software. Third use is checking system components. System software ensures that all the components attached to a computer system are working properly or not. So let's say we switch on the computer and after that there is some problem with the keyboard. Now the system software will check all the components, and if there is any component missing, it will give you some kind of message so that you can rectify your mistake. Okay. Next is it helps in translating the instructions. All of us know that computer understands only 0 and 1, that means the machine language. So system software will help in translating from high level language, means English language, to the machine language. So translating instructions is also one of the most important tasks of system software. Let's see these tasks in details. So let's see the different types of system softwares, which are operating system, language processors, and device drivers. Let's start our discussion with the concept of operating system. So what is an operating system? Let's say we buy a computer. The computer is nothing but a piece of hardware. You cannot use the hardware without a software, that we have already learned a few minutes back. So as a user, you will be thinking, how do I use this computer? Now for using this computer, you require something known as operating system. And once the operating system is installed, the user can use the computer. So how does a operating system help in utilizing the hardware? The operating system helps the user in interacting with the hardware. So what can we say? An operating system acts as an interface between the user of a computer and the computer hardware. So the formal definition of an operating system may be like as follows. It is a system software which acts as an interface between an user and the hardware. So it acts as an intermediary so that you can interact with the computer system. Some examples of operating systems are, most popular example of operating system is Windows operating system. It's developed by Microsoft. Next is Mac operating system. It's developed by Apple. And next, one of the most popular open source operating system is Ubuntu. Okay. Next, let's see the different functions of operating system. How does an operating system help so that we can use the computer system smoothly? It helps in the following ways. The first function of an operating system is, an operating system makes the computer system convenient to use. So if you have an operating system, you can use the computer system conveniently. Next, operating system helps in using the hardware in an efficient manner. So let's say you purchase a very expensive computer which has Intel Core i7, like 16 GB of RAM, 1 TB of hard disk, or maybe solid state drive. But if the operating system is not good, then you cannot use the hardware in an efficient manner. So one task of operating system is to help in using the hardware in an efficient manner. Next function of operating system is, it provides an environment such that all the softwares can run properly. So at first we install the operating system, or it may be pre-installed from the manufacturer also, but all the softwares that we want, like MS Word, like Photoshop, etc. Now how these softwares will run? These softwares will run over and above the operating system. So operating system provides an environment such that all the softwares can run properly. Next function of operating system is, it helps in managing the resources, scheduling, and also plays a major role in memory management. So resources means if we can connect various things to the computer, like printer, joystick, and different medical equipments also. So how these resources are managed? These resources are managed with the help of operating system itself. Next is scheduling. Scheduling means at a time many tasks may be given to the operating system. So which task will be performed first, which task will be performed second, which task will be performed third, all these things are also managed with the help of operating system. So these are the different functions of operating systems. Let's see the interface of different operating system. So this is the interface of Windows 7. So this is the interface of Windows. Like typically Windows 7 has this type of interface. Interface means this is the look and feel of the operating system. If I talk about Mac operating system, this is the interface of Mac operating system. It's developed by Apple. If I talk about the interface of Ubuntu, this is how an Ubuntu interface looks like. Let's go to the next type of system software, which is language processor. See, we know that a computer understands only two digits. Those are 0 and 1. It is known as the machine language. But it is very difficult to learn and understand machine language for humans. Therefore, but we give the instructions in high level language. Do we give the instructions to a computer nowadays using zeros and ones? No, we give it in high level language, typically in the English language. But can a computer understand English language? No, a computer cannot understand English language or any other language for that matter. Therefore, these high level languages using which we interact with the computer needs to be converted into machine language. Now, how this conversion from high level language to machine language is done? This conversion from high level language to machine language is done with the help of what we say as language processors. Okay, so what is language processor? It is a category of system software that converts a source code to machine language. Source code means whatever we give to the computer from outside, it is known as the source code in high level language. So the programs written by a programmer in high level language is called source code. Let's say we are using the Python programming language. So whatever programs we are writing in Python, it is known as the source code. But a computer does not understand source code. It understands what is known as the machine language, or in programming terms we say it to be object code. So what is object code? The code converted to machine language by the language processor is called object code. So we know that language processor helps in converting the source code to object code. What is object code? After conversion, whatever code we get, it is known as the object code. As an example, we can say that let's say we write print hello. It is known as the source code because we are writing it with the help of the keyboard. Now it is converted by language processor into, let's say, somewhat like this. It is known as the object code. After conversion, whatever code we get, it is known as the object code. Now language processors, they can be classified into three types: interpreter, compiler and assembler. Let's see all these three types of language processors one after another. Let's start with interpreter. So what is an interpreter? For understanding it, let's take an example. Let's say we have a person, his name is Ram. We have another person, his name is Sham. Ram understands English and Sham understands only Tamil. Ram understands only English and Sham understands only Tamil. Now, can the communication happen between these two people? No, communication cannot happen between these two people. Therefore, we require a third person. Let's say that third person understands both English and Tamil. Let's name that person as interpreter. Now, if the communication is to take place between Sham and Ram, how the communication will take place? With the help of an interpreter, let us try to understand. Let's say Sham says something in Tamil. What the interpreter will do? Interpreter will convert it into English. Okay. Then Sham will again say the second line. What the interpreter will do? Interpreter will translate it so that Ram can understand into English. Now, one thing to note here is that how the translation is happening. Translation is happening line by line. Who is helping in translating? The interpreter is helping in translation. So what is interpreter? It is a language processor that translates source code written in high level language to machine language line by line. So it is such a language processor which translates the source code written in high level language to machine language. How the conversion is done? The conversion is done line by line. These three words are very important in case of interpreter. Here the translation happens line by line. Don't forget this. Next, let us try to understand about the second type of language processor, which is a compiler. Let's take the same example. We have one person named Ram and we have Sham. Ram understands only English and Sham understands only Tamil. Now, communication cannot happen between these two people because one does not understand other's language. Therefore, a third person is required who understands both English and Tamil. Now, let's change the name of the third person. Now, let's call him a compiler. Now, how the translation will happen, how the compiler will help in translating the sentences of Sham to Ram, let's see here. Now, here what will happen, Sham will say everything that he has to say at once, and after Sham has completed his speech, the compiler will translate everything at once. Okay, this is the difference between compiler and interpreter. So, what is a compiler? It is a language processor that translates source code written in high level language to machine language in one go. In case of compiler, at first the compiler will not play any role. At first, what will happen? You will write the instructions in high level language, and when you are done with writing everything, at the end everything will be translated. That's how a compiler works. Now, before going to the next type of language processor, let's try to understand the generation of computer language in very brief. At the first, we had first generation language. First generation language understood only machine language, that means language which used only zeros and ones. Then we had second generation language, which is assembly language, but always keep this in mind that no matter how many generation languages come, computer can understand only the machine language, that is the first generation language. Third generation language consists of the high level languages, the languages which we use most often like Python, C, C++, Java, etc. Next is fourth generation language, which consists of SQL, Oracle, etc. Basically, these are the database management systems. Next, we have fifth generation languages like Prolog, OPS5, Mercury, etc. Fifth generation languages are basically used for artificial intelligence. Now, sixth generation language is also being developed, which is known as no code language. Here, in case of sixth generation language, without using any code only, you can develop various programs. So, that's about the generation of computer languages in brief. Now, let us talk about assembler. What is an assembler? It is a language processor that translates a program written in assembly language to machine language. We know that computer understands only one type of language known as machine language. So, an assembler translates a program which is written in assembly language into a machine language. So, these are some of the words that are used in assembly language, but computer cannot understand assembly language. So, an assembler helps in converting these into what? Into a machine language. I hope you are clear with the three types of language processor. Let's go to the next topic within system software, which is the device drivers. Let's try to understand what is a device driver. So, it is a special kind of software program that controls a specific hardware device attached to a computer. So, let's say I purchase a printer for my tasks, okay, and I already have the computer. Now, what I have purchased recently, I purchased a printer, but my computer will not be able to recognize this printer. Now, for my computer to be able to recognize the new printer that I have bought, I need a special kind of software which is known as the device driver. So, it is a special kind of software program that controls a specific hardware device attached to a computer. Another example can be, let's say you purchase a new pen drive from the market and attach it into your USB drive. Once you attach it for the first time, it will give you some instructions like installing device drivers. So, device drivers are special kinds of software which is required so that we can run a specific type of hardware. For different types of hardware, the device drivers is different. Typically, whenever you purchase a new device, that device manufacturer gives you the device drivers, okay, so that you don't face any problem while using it in your already in the computer which you already have. Now we are done with system software. Let's try to understand application software. Okay, so let's get started with application software. So we use different types of applications in our day-to-day life. For example, MS Word, it is used for typing letters and different other documentation purposes. Let's say you have to make a project. For making the project, for making the document of the project, you will be using MS Word or any other word processing software. If you have to edit some photos, you will be using Photoshop. If you have to make a presentation, then you will be using PowerPoint or any other presentation software. So what are these? Typing a letter, editing photos, or making a presentation, these are some specific jobs. Okay, so what is an application software? An application software is the set of programs necessary to carry out operations for a specific purpose. If we require a software for a specific purpose, then that is known as application software. Alright, application softwares can be classified into different types like packages, customized softwares, system utilities, and developer tools. Let's start our discussion with the help of packages. So for understanding packages, let's take an example. Let's say we have a school. Now for different activities of the school, different types of softwares are required. For example, MS Word is required for typing something. MS Excel is required for making the salary or some data analysis. PowerPoint is required for making presentations. These are some of the requirements of school. OneDrive is required for storing your data in the cloud. Microsoft Teams is required for conducting online classes or for online meetings with the staff. So, and OneNote is required for taking the notes. Now, all these things can be bundled together into what we know as or what we call as package. Now, in this case, the package is MS Office. So, what is a package? It is a set of related general application softwares. Here, in this case, the package name is MS Office. MS Office is not a software, it is a package within which we will have a set of related software. If we use MS Office online, it's known as Microsoft 365 as of today. So let's go to the formal definition of packages. Packages are a collection of related general application softwares. For example, if I purchase the Microsoft Office package, I'll be getting these softwares. Similarly, there is a package from Adobe also. If I purchase the package of Adobe, I'll be getting Photoshop, Lightroom, Premiere Pro, and all these things. Okay. Next, let's go to customized software. Customized means if someone makes something only for you or only for a small group of people, it's known as customization. Here, let's take an example here. Let's say we have a school called ABC Public School and we have another school called DEF Public School. Now different schools, they require something known as school management system. It is a software which is required by different schools. Now the working procedure of ABC Public School and the working procedure of DEF Public School, will it be same? Many things will be same, but many things will be different also. Therefore, the school management system built for ABC Public School will not be effective for DEF Public School. Therefore, customized softwares are required. Similarly, banks require a type of software known as banking management system. Here I have taken two banks as an example. One is State Bank of India, other is the Axis Bank. Now the software developed for State Bank of India cannot be used by Axis Bank, and the software developed for Axis Bank cannot be used by State Bank of India. Why? Because their working procedures will be different. Therefore, customization is required. So, what is a customized software? The type of softwares that are designed according to the requirement of a particular business or organization is called customized software. Now, if a particular software is developed according to the requirement of a particular business organization, then it is known as customized software. Now, you may ask me, sir, whether MS Word is a customized software or not. No, MS Word is not a customized software. It is a general application software, because anyone can use that software and can take the benefits of word processing. Okay. Next, let's go to system utilities. What are system utilities? These are the application softwares that assist the computer by performing the housekeeping functions. Housekeeping functions mean it will do the general maintenance activity of a computer, like disk backup, scanning the computer system, cleaning the viruses with the help of various antivirus softwares like Norton and Quickhill, and various other antivirus softwares are also there, and arranging information properly. These are housekeeping functions. Now, who will help in managing these housekeeping functions of a computer? System utilities will help in managing the housekeeping functions of a computer. Next, let's go to developer tools. What are developer tools? Let us see. These are the softwares used by programmers to create, test and debug a software. Let's say I have to create a program. Now, for creating a program, I will require various tools. Like if I am creating a program with the help of Python, I will be requiring ideally. If I am creating with the help of Java, I will be requiring NetBeans. If I am doing some kind of web programming, I may require Sublime editors. What are these? These are developer tools. Means these are softwares that are used by programmers to create program, to test a program, and to debug a software. What is the meaning of debugging? Debugging means when you develop a program, often various types of errors will come. Now, what you as a developer will have to correct those errors. Correction of error is known as debugging. These developer tools has the facility of creating the programs, testing the programs, and also debugging the software in case of any errors. Okay. Now, at the end, I would like to show you the working hierarchy in a computer. Now, at the extreme internal, we have the hardware. Means as I purchase the computer, what I am purchasing? I am purchasing the hardware. Hardware consists of the parts which we can feel and touch, like CPU, keyboard, mouse, printer, etc. But we cannot run the hardware individually. For running the hardware, we require something known as system software. This is just like a revision. And system software consists of operating system, language processors, device drivers and utilities, as we have seen in this video itself. Now, within above the system software, we install this application software. Application software means softwares for specific purpose, like word processors like MS Word, spreadsheets like MS Excel, photo editors like Adobe Photoshop, some kind of graphic design software, some kind of presentation softwares like PowerPoint, or some kind of database management system like SQL. So, all these application softwares run over system softwares, and system softwares will work over the hardware. This is the entire working hierarchy in a software. Okay, I hope that this session was useful. Thank you very much. I'll see you in a different session. Thank you very much.